Hi guys, good evening. Let's wait for another minute and then we'll start. Let's check what's happening at the YouTube front. Have people joined? Hi guys, good evening. Okay, so let me start. So yesterday we had done some operations on the linked list. So manipulation operations like create, read, and add first, last, middle, delete first, last, middle. Okay. So today let's try to do operation. Okay, searching would be just similar to display. Searching would be quite similar to display. So if I would want to search for a number, okay, I would use this. I would want to search for a number. Enter the number to search. And we'll take it in search. And we'll call search in the list head and the number to search. Yeah. So it will return me the position. So if it is found, I'll return. Okay, so if position is equal to -1, I'll say not found. Else also found. So if it is not found, it will return me minus. This function is not there, let's create it. So we'll take a node temp while the temp is not equal to null. And we'll check if the temp dot data is equal to the number that I'm searching for. Okay. So we will, okay. We'll return 1, and after the loop will return minus. So okay, temp has not been initialized, so temp will be initialized to head. So we'll try to do it like this. So we'll start from the head till we don't get null. If any data matches, I'll return 1. And if this point is reached, means no data has been found, so return minus. The -1 is there in position, then we'll say not found, else we'll say found. Okay, so let's try to check this out. Yeah, we'll have to increment the temp. Yes, correct. Else we'll go in infinite loop. Temp equals to temp dot next. Yes, correct. So that is what I'm going to do. Infinite loop. Right click, run as Java application. Yeah. Let's start the size of 3. 1, 2, 3. Displayed the list. Let's add 4 at the start. Let's add 5 at the end. Let's enter the position 4. Let's add 6. So 6 is added at position 4. First node is deleted, so I'm left with 1, 2, 6, 3, 5. Last is deleted, I'm left with 1, 2, 6, 3. And now if I say position 2, so I'm left with 1, 6, 3. And now in 1, 6, 3, I want to search for a number. So if I say 3, we'll say found. Why is it calling again display? So I don't want to call display. So I don't want to call display over here. Okay, so here, this is what we're searching, when linear search over here. Then sorting, if you want to sort the linked list, okay. So directly, let me then bypass all these methods and directly after creation, we'll sort. So directly after creation, I'll comment all these methods now. As I create, I'll display it. And then I'll call the sort, passing the head, and I'll display it after sorting. Function is not there created. So let's start with the, okay, we had done selection sort, right? So let's take any sorting technique. Let's take selection sort. So what were the logic of selection sort? Let's copy this and let's try to apply that over here, see how it works. So I is 0, so I'll take 2 nodes, node I, that will also be at head, and I'll take node J, that will also be at head. So here it's selling. Okay, so let's just declare 2 nodes, node I and node J. So I is equal to 0 means I starting at head, and less than br dot length means, how do we know it's not the end? Not equal to null, right? We use not equal to null. So I not equal to null, and how do we increment the, we increment it like this, correct? So we will say I is I arrow next. Perfect. Let's go with J. So where will J be? J will be one step ahead of next always. So J will be one step ahead of next. So J will be I dot next. J will also go till null. And J also will increment by 1. Okay. Then now what do I check? Element at I. So if I dot data is greater than J dot data. So we swap. So we need a temp variable, and we are swapping integers. So in temp will be int. So I dot data will go into temp, and j dot data will go into I and temp will go into j dot date. Save it. Okay, so the same thing which we have done, just I'm playing around with pointers. So you should be familiar with these logic. Okay, so I've committed everything else, and all I've kept is just the sorting one. So let's try to run this and check how it works. So if I enter 5, 5, 3, 1, 4, 2. So before sorting 5, 3, 1, 4, 2, in ascending order sorting 1, 2, 3, 4, 5. So if you want to sort it in ascending sort, then use ascending sort. And if you want to do it in descending order sorting, let's try to do a descending order sort also. Rename this function as ascending sort. Let's make another function for descending. That too, that will just reverse this. So let's display after ascending. Like 5, 3, 9, 1, 6, 1, 3, 5, 6, 9, 9, 6, 5, 3, 1. And before sorting the original line. Such operations you all can try to perform on your linked list. Okay. One very common question asked is, how do you reverse a linked list? Okay, this would be interesting. So for reverse a linked list, we'll have to again go back to the drawing board, and to explain you all the iteration, we'll have to do some sort of drawing. But data structures, you always have to draw it parallel. Data structure has to be parallelly, drawing has to go on. Let me know once you are able to see the paint screen. This is my original linked list. Data part, next part. Restricted to 3, 1000. Ten, 2000, 20, 3000, 30, and none. And here it is having 1000. Now if I need to reverse a linked list, the arrows are going towards left to right. So what I'll do is I'll take 3 pointers now. I'll call them as the left, current, and right. A bit bigger, but I have to put the address into it. So left, current, and the right. So I'll initialize the left with null, the right also with null, and the current with the end. I'm calling this as my left, current, and right. Okay, so made 3 pointers. So let me write the code over here parallelly. Node left is null. Node right is null. And node current is the end. Now I will iterate it till the end. So I will iterate this till my current is not null. My current is not equal to null. And these are the iterations what you need to understand. Okay. So this loop is what you need to understand. How this loop will iterate. If you understand these iteration mean reverse logic will go into your head. With some code over here. So first thing first, what I'll do is I'll take the next part of where the current is pointing. Okay, and stored in the right. So this will be my first. Take this and store it in the right. First populate the right part. So what did I just do over here? If I write it down, I will say what? The current dot next has gone into the right. Correct? So the current dot next has gone into the right. Now once that is done, second step would be put the left in the current dot next. So copy whatever is there from the left and put it in the step number 2. So what did you say to this? Left has gone to current dot next. Which two steps done? And then left shift. Whatever is in current, put it in the left. Whatever is in current will go in the left. And whatever is in right will go in current. Just left shift. So what I do just over? Whatever was in current went to left. Whatever was in current went to left, and whatever is in right will go to current. Whatever is in right will go to current. Whatever is in right will go to current. Okay. So now these three have moved a bit ahead. So where is the current? At 2000. So they have progressed over here. Okay. And this now has been eliminated because it is pointing to null. This has been removed. Now let's check again. Current is not equal to null. Yes, true. Current is not equal to null. True. Whatever is current dot next. Current is 2000. What is 2000 dot next? 3000. Put it in the right. So take this and put it over here. Whatever is in left, put it in the current dot next. What is the current? 2000. 2000 dot next is this. So whatever is in left, put it over there. So now, where is 2000 pointing to? 1000. So arrow has been reversed. The arrow has been reversed. Now just do a left shift. Whatever is in current will go into left. So what is in current? 2000. Put that in the left. And whatever is in right, put into current. Where is the current? 3000. So let's move over there. Loop will again run. 3000 not equal to null. Very good. So current dot next. What is 3000? Will go where? In the right. This will come here. And the left will go in the current dot next. So what is left? 2000. That will come here. So now the arrow has been reversed because now 3000 is pointing to 2000. And left shift. Whatever is it current will go in the left. And whatever is in right will go in current. Okay. And these three have moved ahead. Current not equal to the loop is false. So what is my new head now? So the head which was at 1000. Now what is my new head? My new head is now left. So once the loop breaks, once the loop terminates, I'll return the left. Because that is my new head. And this is the function to reverse the linked list. So let's go and code this. Okay. I'll comment out the ascending also. Directly, let's move on to the business part. That reverse list. Passing head and it will give me a new head. Okay. And then we can display the list after reverse. Display after reverse. Function is not there, it's created. So I've got the head, I need 3 pointers. Tell me node, left is null, node, current is the head, and node, right is null. While my current is not equal to null, so do one thing first. Put the current dot next into the right. Then put the left in the current dot next. And then put the current in the left and put the right in the current. And once the loop breaks, I will return the left. So let's check. This is working fine. Size 5. Enter random numbers. 43716. 43716 after increase. So these are your ways of reversing a linked list. Okay. Then we can merge two linked lists. So if we have to merge two linked lists, then we'll require two heads. So I'll have to make more two heads now. So I'll say node head 1 is null and node head 2 equals to null. And we'll create two linked lists. So head 1 by passing head 1 to create, and head 2 by passing head 2 to create. Okay, so now I have got two linked lists. So how do I merge them one after the other? Okay, this is done, right? I'll save it for you guys if you all wish to. Now we've got two linked lists with two heads. So linked list 1, 1000, 2000, 3000. And this is linked list 2. One, 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 two, 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 three, 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 three. So I have 10 and 2000, 20 and 3000, 30 and 11. And have 11 and 2222, 22 and 3333, 33 and 11. And head 1 and head 2. So how will you merge these two linked lists? Pointing to 1000, pointing to 2000, pointing to 1111. So we'll traverse till the last node of the first list. So we'll take a temp. We'll take a temp and traverse this till the last of the list. So how would that go? That would be while temp dot next is not equal to null, and increment the temp. Temp is temp dot next. By this loop, the temp will come till the last node of the first one. Okay, and we'll initialize the temp to head 1. We'll initialize this to node temp equals to head 1. And after the loop terminates, my temp is at 3000. And after the loop terminates, what will I do? Temp dot next will be head 2. We will return the, okay, so once this becomes means what? This list as which was null now gets added to this list. This becomes into a one single linked list. So which is the head of that entire single joint linked list? Head 1. So I'm returning that. So here now I'll have 1 1 1 1. Return what? Head. So let's try this. Now I've got two linked lists. Head 1 and head 2 both are null. Created both of them. So I'll say head 1 equals to merge class head 1 and head. Okay. Or you can make a new head, let's say head 3. That would be the head of the merge list. Let's say head. Let's create this function. So make a temp which will be from head 1, and while my temp dot next is not equal to null, increment the temp, and once the temp breaks, we'll do temp dot next equals to head, head 2, and we'll return the head 1. And then if you want to see display after the merge list, then we'll pass head 3. Okay, so let's try to comment out the creation. So I'll comment out this code also. And now I'll comment out the singly linked list creation also. Okay, now we can start with the two lists. Okay. So now this is the first linked list. So I'll say 3, 10, 20, 30. Second linked list, I'll say 3, 11, 20 to 33. And then 10, 20, 30, 11, 20 to 30. So if you want to merge and remove the duplicates from the list, then that you want the linked list, merge them and remove the duplicates. Like we want to form a union. We want to form a union of the list. So how will we do that? Any guesses? Form the union of two lists. So one thing which I can use is, once I have formed the list, I'll reverse it. Not reverse, sorry, we'll sort this. We'll sort it. So we'll try to sort it. Which list? Head 3. Okay. So after sorting, I'll directly display it after. So first I'll merge it. After merge, I'll sort it, and then I'll display it. So let's check. 10, 20, 30, 11, 22, 33. Oh no, sorry. I entered too huge amount. So 3, 10, 20, 30, 3, 11, 22, 33. Now it is sorted. So if I would enter duplicate values, 10, 20, 30, and then 3, 10, 40, and 50. So here I have 10, so I will check for the adjacent number after sorting. If they are same, I'll take only one. If they are same, I'll take only one and move ahead. So how will we do that? Then we'll call the union function and pass head 3 to it. Okay. And that will give us the union of these two linked lists. So let's create this. Okay, so if I have a linked list of this nature, I want to remove the duplicates. So who can help with the logic if this is the linked list? This is the linked list. This is the linked list. 10, 10, 20, 30. So 10 is at 1000, 2000, 3000, 4000, 5000, and 6000. So 10 is having next as 2000. Anybody can figure out the logic and share it with me over the chat. So what logic will apply? So 10 is there, and again 10 is there. Let's say 20. Assuming there is another 20, and there is 30, and there is 40. 2000, 4000, 5000, 6000. Head 3 is at 1000. This is the head 3, and this is null. And this is how we have formed the merge linked list. Now I want only one element. So what will we do then? And then we'll get the temp over here. So temp will be at the head. Head is at 1000. Head 3 is not null. Head 3 is 1000. Okay. So if I do this while temp not equal to null, if temp is equal to temp dot next, then temp will increment. Right? So so while my temp is not equal to null, 1000 not equal to null, if temp is equal to temp dot next, means temp dot data, right? It is equal to temp dot text dot data. You have to check for the data. So temp dot data is 10, and next data also is 10. If it is equal to, then directly move ahead and say temp is temp arrow next. So, but Yeah. So if it is equal, then we don't need this, right? So we can directly move the temp dot next to the next one. Yeah. You can just move it. So now what I'll do is if 10 and 10 are both are same, what I'll do is the temp dot next, that is 2000, will point to temp dot next dot next. So 2000 dot next is 3000. So directly I will make this point to 3000. Okay. Okay, let's check that out. So this has been eliminated. So now it is pointing over here. Okay. Now we got to check various permutation in this. Okay. Then we'll try to increment the temp. Okay. So temp should also move ahead. Temp should also move ahead. So now the temp will move ahead. So after this, if temp equals to temp dot next. So what is temp dot next? 3000. Directly temp will go to 3000. Three thousand dot data and 3000 next dot data is same. So temp dot next. So temp dot next is 4000. 4000 dot next is 5000. 5000 will come over here. Right? So this will point to 5000. This is eliminated. And temp is temp arrow next. Temp comes to 5000. Temp becomes 5000. Okay. 5000 dot data is 30. 5000 is 40. Is not equal, then directly temp is temp arrow next. Temp becomes 6000. Okay. The temp comes to 6000. So now once temp comes to 6000, there is no. So while I can say, while temp dot next is not equal to null, because now it is, there's nothing to compare, right? So instead of saying while temp, because now 6000 dot next is null. So in the last there's nothing to compare. So I will just say what? While temp dot next not equal to null. So 6000 next not equal to null is false and the loop will break and I'll return the new head, that is head 3. So let's try to check this out if it's working. Okay, so once we have done the union, it's the union function over here. So let's take a node temp, start it with head 3. What did I say? While my temp dot next is not equal to null, come inside. If my temp dot data is equal to temp dot next dot data. Well, able to see my screen, right, guys? So if my temp dot data is equal to temp dot next dot data, what to do? Just say temp dot next will be temp dot next dot next. And then we have to increment the temp to go to the next node, temp dot next. And once you have got, you return the new head and head 3. And then after your union, you can display. Display after union. So if you directly want to display after union, you can do that also. Let's check this out. Right click, Java application, 3. So what did I enter? 10, 20, 30. And second, I entered again 10, 20, 40, right? 10, 20, and 40. See over here, after the union, only once it is taking, not more than that. So such operations you all should be able to perform on the linked list. Okay, we tried to cover lots of various questions which can be asked in the interview. So almost most of them we have covered in this. So this becomes a good cheat code for you guys. This becomes a good reference point for you guys. And I have printed diagrams also. Whenever possible, I have stored the diagrams. But I have overridden most of them. I doubt I'll be having the diagrams. So I'll just save this and I'll push on to the Git repo and share all the Git repo link. Okay, let me check what's happening at the YouTube end, what we are sending. All good, guys? Those who joined by YouTube. So I hope you all understood linear linked list comfortably. Same with the guys who joined through Zoom. So let me post this code over GitHub and share on the link. Just be with me. I'm just searching for you guys a repository. It was our day 12, right? I just put this code to the repository and share on the link. They want the code which you said, yes, while temp.next not equal to null, right? Yeah, yes. Shared the GitHub repo with you all over the Zoom chat. And I've also refreshed the GitHub repo to the guys who joined through Zoom. I hope linked list was pretty much understood. Tomorrow we'll spend some time with doubly linked list, and if time permits, we'll start with trees tomorrow. Okay, we'll try to do the binary tree, binary search tree, traversals, and some questions regarding the trees. Okay. I also wanted to discuss hash map with you all. A lot of questions require the understanding of hash map while solving these aptitude questions, technical round questions. So I want 1 or 2 sessions for the hash map also dedicated. Okay. So we'll plan that out. We've left with today was a 12th session. So we're left with 3 more sessions, Thursday and Monday and Tuesday. So accordingly, we'll plan that out as to how we can accommodate hash map and trees. Okay. I've shared the code and Amar sir has shared the attendance. Please look at the code and mark your attendance for the day. Those who have not marked yet. Okay, Amar sir, do you want to make any announcement? Hello?
No, sir, all good.
Okay, thank you.
Oh, thank you, students. We'll see you tomorrow. Bye bye.